Welcome back, everyone, to another explainer. I am absolutely thrilled to have you here today because we are looking at a massive, and I literally mean massive, leap forward in wearable artificial intelligence. For a long time, we've talked about AI as this tool that just lives inside a box, right? Your phone, your laptop, your desktop. But what happens when that AI actually breaks out of the box? When it sees exactly what you see, hears exactly what you hear, and has the power to actually do things for you out in the real world? Well, today we are exploring a really fascinating new system called VisionClaw.
Before we even get into the tech, I want you to think about your own daily routine for a second. Ask yourself, how often do you actually have to pull out your phone just to give your AI context about your physical world? Say you see a concert poster on the street. You literally have to take out your phone, open an app, snap a picture, and type, "Hey, add this to my calendar." Or you're holding a completely empty carton of almond milk. You've got to find your phone, open Amazon, search for the brand, and add it to your cart. There is just a massive layer of friction there. You're constantly having to manually translate the physical world into the digital world just to get the AI to help you out.
Okay, let's dive into the core problem the researchers are trying to solve here. On the left side, we have current AI. It's incredibly smart, sure, it can draft emails and navigate the web, but it is entirely screen-bound. It's completely blind to your physical surroundings. On the right, we have current smart glasses. Now these can see the world, they can hear your voice, but they are totally passive. They might be able to answer a trivia question about whatever you're looking at, but they cannot autonomously execute a multi-step digital task for you. Neither of these approaches on their own really gives us that science fiction dream of a truly helpful, ambient assistant.
So moving to Section 1, enter VisionClaw, bridging the gap.
The researchers have designed an open-source, always-on, wearable AI agent that actually connects real-time egocentric perception with general-purpose task execution. Put simply, it doesn't just look, it does. And what's really interesting about this slide is how elegantly they stitch together existing technologies to make this a reality. If you look at the three layers here, on the far left, the wearable layer uses standard Meta Ray-Ban smart glasses to continuously stream audio and video. In the middle, the multimodal AI layer uses Gemini Live. Because Gemini Live natively processes audio, there's no clunky speech-to-text delay, It just understands the raw audio and video in real time. And finally, on the right, the magic happens, the agentic execution layer. When Gemini realizes you actually want to take an action, it sends a tool call to an open-source framework called OpenClaw, which can securely access your browser, your email, your calendar, and your smart home devices to actually execute the task.
To make this super concrete, let's walk through this three-step see and act loop. Step 1 is capture. Imagine you're holding a pair of headphones in a store, and you just say, "Find these on Amazon and add them to my cart." The glasses capture the audio and a snapshot of those headphones. Step 2 is process. Gemini Live identifies the exact model of the headphones based on the image and your command. And step 3 is execute. OpenClaw takes over, opens a hidden browser window, searches Amazon, clicks add to cart, and Gemini just whispers right in your ear, "Done, it's in your cart." 3 steps, completely hands-free without you ever touching a screen.
Which brings us to Section 2, the performance leap, proving the tech.
Now, it's one thing to build a cool architecture diagram, right? But how does it actually perform when human beings use it compared to our current screen-heavy methods? Well, the researchers put this to the test in a really rigorous laboratory study. They give 12 participants 4 incredibly relatable physical tasks to complete. First, note-taking. Looking at a physical grocery receipt and asking the AI to log those items into a Notion database. Second, email composition. Looking at a printed academic paper and telling the AI to draft a collaboration email to the lead author. Third, product lookup. Looking at a book and buying it if it actually has good reviews. And fourth, device control, just turning off a smart light. They compared VisionClaw against systems where the user either had to do the task manually on a phone or had to explicitly type out all the visual context themselves.
And the results were honestly striking. Participants using VisionClaw achieved up to a 37% faster task completion rate compared to the baseline where they had smart glasses but no autonomous execution. When you eliminate that need to manually transcribe the physical world into a digital interface, things just get done much, much faster.
And this data brilliantly illustrates the human impact of that speed. This is from the NASA Task Load Index, which measures cognitive workload. Look at the VisionClaw column right there. Mental demand, temporal demand, and frustration were all rated the absolute lowest. The highest frustration actually came from the always-on only condition. That's where the glasses could see the receipt or the book, but the user still had to take out their phone to actually write the note or buy the item. The participants literally said things like, "I still have to do things manually in the end." VisionClaw just completely removed that frustration by closing the loop.
All right, Section 3. Life with always-on AI. Emergent behaviors.
The researchers didn't just stop in the lab, though. To truly understand an always-on wearable AI, you kind of have to wear it all the time. In a longitudinal deployment study, out in the wild, without any scripted tasks, the researchers observed users organically developing 6 distinct emergent use categories. They used it to communicate, like managing inboxes while they were walking. They used it to retrieve information situated in their environment. They used it to save memories and documents completely hands-free. They triggered recall of past events. They shopped for physical items they encountered. And they used it for control of their digital and physical environments. Grounding this in reality, the point of view shots on the left show exactly what this looked like in practice. One user is looking at a physical event poster on a bulletin board and just says, "Hey, send this poster to our Slack channel." Another user walks into a coffee shop they haven't visited in months, looks at the menu board, and casually asks, "What did I order here last time?" The AI checks their calendar, their past emails, and bank receipts and whispers the answer right in their ear. The sketches on the right highlight how AI assistance shifts from being this focused, sit-down desktop activity to becoming an ambient part of navigating a city or a grocery store.
Now, one of the most profound takeaways from this field study was how screenless interaction completely changed the user's state of mind. Delegating tasks to VisionClaw felt much calmer than using a phone. Think about it. Instead of staring at a loading bar on a screen, you just ask the AI to do something and you keep walking or cooking or brushing your teeth. But this calmness demands immense trust. The study noted that users felt perfectly fine having the AI turn off a light or draft a note, but they really hesitated to let it send a high-stakes email to an important contact without letting them double-check a screen first. We are for sure still adjusting to this idea of invisible delegation.
The researchers also discovered a truly fascinating data network effect. On day 1, users mostly asked for the weather or basic product searches. But over weeks of use, as the system accumulated a memory of their daily lives, their calendar, their emails, the things they looked at, it became exponentially more useful. The AI started chaining tasks together. A user could say, "Tell me more about the person I'm meeting next," and the agent would seamlessly cross-reference their calendar, search the web, check their past emails, and provide a comprehensive briefing directly into their ear as they walk to the meeting. It's a real game changer.
Let's head into Section 4, the future of interaction, from commands to context.
What we are seeing here is not just a cool new gadget, it's an entirely new paradigm for human-computer interaction. The crucial point is captured perfectly in this quote straight from the research paper. Always-on agentic systems reshape interaction from discrete, command-based usage to continuous, context-driven engagement. Instead of treating AI as a distinct, separate tool that we occasionally pick up and use, VisionClaw shows us a future where AI is an ambient, lifelong partner, one that is always there, sharing our context, and ready to act on our behalf the exact moment an opportunity arises.
So I want to leave you with a highly provocative question to chew on. As this technology scales, as we move to smaller glasses, better batteries, and more advanced agents, what happens when an AI accumulates the memory of your entire life and actually has the autonomy to act on it? The utility we saw today is absolutely incredible, no doubt, but the implications for how we live, how we remember, and how we protect our privacy are immense. Thank you so much for joining me on this explainer. Stay curious, keep learning, and I'll catch you in the next one.